Hi everyone. Today we're going to study angles, particularly the angles in standard position, also degrees and radians. Let us define an angle. An angle is the union of two rays having a common endpoint. The endpoint is called the vertex of the angle, and the two rays are the sides of the angle. In the figure, the two rays are here, the ray D and ray F. The point E is the vertex, that is the common endpoint. This angle is named angle. This symbol is used to denote an angle. So this is angle DEF. Greek letters or sometimes capital letters are used to denote an angle. The symbol theta is used. Also the symbol phi. This is alpha. And the symbol beta. The symbol gamma. The capital letters A, B, C, and so on. Let us draw now the angles in standard position. Think of two horizontal rays lying on top of one another. Leave one ray fixed in place and rotate the other. I have here the figure. The fixed ray is called the initial side. The rotated ray is the terminal side. The vertex is somewhere here. And we can see the amount of rotation as shown by this arc with an arrow showing the direction of the rotation. Let us define positive or negative angles. If the terminal side is rotated in a counterclockwise direction from the initial side, the angle is said to be a positive angle. In our figure here, the initial side is fixed horizontally, then the terminal side is rotated on a counterclockwise direction. The angle formed here is positive. If the terminal side is rotated in a clockwise direction from the initial side, the angle is said to be a negative angle. Let us define measure of angles. The measure of an angle is the amount of rotation from the initial side to the terminal side. There are two measures here that we will consider. The first is degree. Second is radian. Let us start with a definition of degree. 1 degree is 1 over 360 of a circular rotation. So a complete circular rotation contains 360 degrees. An angle measured in degrees should always include the unit degrees after the number. The symbol is like a small exponent 0 after the number. We have an example here, 90 degrees. Let us define now radian. 1 radian is the measure of the central angle of a circle such that the length of the arc between the initial side and the terminal side is equal to the radius of the circle. Look at this figure. This is our radius. and this arc subtended by this angle is equal to the radius itself. So the angle here is equal to 1 radian. A full revolution that is equal to 360 degrees equals 2 pi radians. Consequently, a half revolution that is equal to 180 degrees equals pi radians. More so, the radian measure of an angle is the ratio of the length of the arc subtended by the angle to the radius of the circle. Take note, when an angle is described without a specific unit, it refers to radian measure. Example, angle of 2 units. This means this 2 is in radian measure. Today we're going to study types of angles. Let's start with right angle. It is an angle that measures exactly 90 degrees. Here is a picture of a right angle. For a right angle, there is a special symbol that denotes a right angle. That small square on that corner there, that means this angle here is 90 degrees. The next angle is acute angle. It is an angle that measures between 0 degree and 90 degrees. This is a picture of an acute angle. Some examples of acute angles are 30 degrees, 45 degrees, and 60 degrees. The next angle is called straight angle. It is an angle that measures exactly 180 degrees. Here's a picture of a straight angle. It looks like a straight line, that's why the name is straight angle. The next is obtuse angle. It is an angle that measures between 90 degrees and 180 degrees. This is a figure for obtuse angle. Some examples of an obtuse angle are 100 degrees, 120 degrees, and 150 degrees. The next is 1 revolution or full rotation. It is an angle that measures exactly 360 degrees. Here's a picture of 1 revolution or full rotation. In this angle, the initial side and the terminal side coincide. Another angle is the reflex angle. It is an angle that measures between 180 degrees and 360 degrees. Here is a picture of a reflex angle. Some examples of reflex angle are 200 degrees, 270 degrees, and 300 degrees. Now let us have types of groupings of angles. The first group is complementary angles. These are 2 angles whose sum is 90 degrees. Some examples of complementary angles are 45 degrees and 45 degrees. Another pair is 60 degrees and 30 degrees. Another pair is 80 degrees and 10 degrees. The next group is supplementary angles. These are two angles whose sum is 180 degrees. Some examples of supplementary angles are 90 degrees and 90 degrees. Another pair is 100 degrees and 80 degrees. Another pair is 170 degrees and 10 degrees. We can see that the sum of each pair of angles is 180 degrees. Another group is called adjacent angles. In the figure here, the two angles are the angle X and angle Y. For adjacent angles, they have common vertex and common side. The common vertex is the point A, and the common side is the side AD. Another group is called vertical angles. We can see vertical angles in the intersection of two lines. In the figure here, the angle X is also there on the other side, and these angles X and X are vertical angles. The same is true with the angle Y and another angle Y here. This is another pair of vertical angles. Example 1. In the figure below, lines AB and CD intersect at O. If angle AOC plus angle BOE equals 70 degrees and angle BOD equals 40 degrees, find angle COE and angle BOE. Let's begin with the angle COE, and this is the angle. Note that AB is a straight line, and rays OC and OE stand on it. That means the angle AOC plus the angle COE plus the angle BOE equals 180 degrees. On the left side, we can rearrange the angles. We can group the angles AOC and BOE together. In the given, the sum of angle AOC and angle BOE is 70 degrees. So we can substitute the value here. So we have 70 degrees plus angle COE equals 180 degrees. The 70 degrees we will transpose to the right. So the right becomes 180 degrees minus 70 degrees. The difference is 110 degrees. This is the angle COE. Let's write this value in here. Now take note that there is a reflex angle COE. From here, it goes in here. So reflex angle COE equals 360 degrees minus 110 degrees. So this is 250 degrees. This is the value of the reflex angle COE. Then let's compute for angle BOE. Note that CD is a straight line and rays OB and OE stand on it. So we can write angle COE plus angle BOE plus angle BOD equals 180 degrees. We can substitute the values for angle COE and angle BOD. This angle COE is what we derive from A. So it becomes 110 degrees plus the angle BOE plus the angle BOD is given as 40 degrees equals 180 degrees. We combine 110 and 40 degrees into 150 degrees. Then we transpose 150 degrees to the right. So the right side becomes 180 degrees minus 150 degrees. And the difference is 30 degrees. This is the angle BOE. Example 2. In the given figure, angle PQR equals angle PRQ. Prove that angle PQS equals angle PRT. Note that ST is a straight line and ray QP stands on it. That means the angle PQS and angle PQR are linear pair. So we can write angle PQS plus angle PQR equals 180 degrees. We can transpose this angle PQS to the right. So the angle PQR will be isolated on the left. And this is equal to 180 degrees minus angle PQS. Let this be equation 1. Now, let us note again that ST is a straight line and ray RP stands on it. That means the angle PRT and angle PRQ are linear pair. Thus, we can write angle PRT plus angle PRQ equals 180 degrees based on the definition of linear pair. So we can isolate the angle PRQ. This angle PRT we transpose to the right. So the angle PRQ equals 180 degrees minus angle PRT. Let this be equation 2. Now, given in the problem that angle PQR is equal to angle PRQ, let us equate now the equations 1 and 2. So the angle PQR is now replaced by 180 degrees minus angle PQS equals this angle PRQ is now replaced by 180 degrees minus angle PRT. From here, we can cancel the 180 degrees from both sides. And then, we multiply this equation by -1. So we can see that the angle PQS equals the angle PRT. Example 3. In the given figure, x plus y equals w plus z. Prove that AOB is a line. Note that in the figure that x plus y plus w plus z equals 360 degrees. We can see that this is a complete angle. In the given, x plus y equals w plus z. This value of w plus z as x plus y, we will substitute in the first equation here. So the first equation becomes x plus y plus x plus y equals 360 degrees. When we simplify, the left side becomes 2x plus 2y. Then we can factor out the number 2. We have 2 times the quantity x plus y. Let's divide this equation by 2. So x plus y equals 180 degrees. This is the definition of a linear pair. So, since x plus y form a linear pair, AOB is a line.